5 and 6. So we have started model 4. So very important part is to solve the numericals based on gravitational force. While solving the paper of CET, NEET and JEE, each and every student can easily answer the theoretical questions, no doubt. We can answer the dimension, we can answer the unit, we can answer the statement whether it is true or false. Everything is possible, but the difficulties is in numericals. So the formula which we have studied is F is equal to capital G m1 m2 upon r square, where m1 m2 masses of particle, r distance between them, and value of capital G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Right? Yes. Those who want to note down it again, they can click on link, they can pause the video and they can note it down again. Right? Because now we don't have to waste our time to note down each and every step mentioned on the screen. Now, first question. Two bodies of masses 5 kg and 6 into 10 raised to 24 kg are placed with their centers 6.4 10 raised to 6 meter apart. Calculate the force of attraction between the two masses. Also find the initial acceleration of the two masses. What the hint they have given? Assume that no other force acts on them. Now, in this given, m1 is equal to 5 kg, m1 is 5 kg and m2 is 6 into 10 raised to 24 kg. So now r is equals the distance from their center is given 6.4 10 raised to 6 meters, right? Yes. Now moving ahead, to find F is equals capital G m1 m2 upon r square. So initially what we will do, F is equal to, note down the formula, that is G m1 m2 upon r square. Putting the values, simultaneously you also can solve and check your answer whether it is correct or not, right? Because writing it from screen is much easy, but solving by yourself will let you know whether you are right or wrong. So 6.67 into 10 raised to minus 11, the first value of G we have written. Second is m1, that is 5 kg, and m2, that is 6 into 10 raised to 24 upon the distance between them is 6.4 10 raised to 6 meters. But looking at the formula, r square is there, that's why we have mentioned the whole bracket square over here. So 6.67, it is by mistakenly printed 7 at the bottom. 6.67 into 5 into 6, and we have taken the powers aside. So 10 raised to minus 11 and 10 raised to 24 together. So minus 11 plus 24, 6.4 square, and the power which were having 10 raised to 6 raised to 2. So 6 2s are 12. So if we need to calculate the values of it, so log 6.67, first one, plus log 5, plus log 6, then minus 2 log 6.4. Now what will happen to 10 raised to minus 11 plus 24? It became 30, and the 12 which is at the bottom will go up, and that became minus 12. So minus 11 plus 24 minus 12 became 10 raised to 1. So we have we have written 10. Now it is most important to calculate this log. So if you have log table, you can calculate it from log table. Log 6.67. How to calculate? We will go in the row of 66. Then 7. The value is 8241. So we have mentioned 0.8241. The first value of log 6.67. Now similarly we can note down the value of log 5 from the log table in the column of in the row of 50 and in the column of 0. So that value is 6990. 0.6990. Similarly we can calculate the value of log 6. We'll go in the row of 60, then 0, then 7782. So value must be 0.7782. So those who does not understand to calculate values using log table, so we have already mentioned everything very clearly. Based on that, you people can write the values using log table, because at the end everyone struggles for the values. Formulas are known, right? Concepts are again known, but the issue is calculation or getting the values from log table. Now moving ahead, addition of all these 3 is 2.3013. You have two options. You can add it in the next step, or you can directly add it. So log 6.4. Now we went into 64, then 0. So the value is 8062. 0.8062 multiplied with 2 into 10 as it is. So the answers after multiplying 2. So we need to find 2.3013 minus 1.6124. The answer is 0.6889, obviously into 10. Now the time to find anti-log of 0.886889. So how we will find? We'll first go in the column of 0.68, then we will choose 8, and finally we will choose 9. That is mean difference. So 4, 7, 8, 6, 4, 8, 7, 5 and 10. So what we have done with that? 4,
8, 7, 5 plus 10.
Plus 10. So that became
4.885.
4.885. So whatever may be the mean difference, we have added into the value which is needed into 10. So this is our final answers. Now what they have asked, first we have calculated the force of attraction between two masses. Now we have to calculate, find the initial acceleration. So for initial acceleration, F is equal to
MA.
mass into acceleration. So considering this formula in terms of acceleration, that became capital F upon M. So M1, for M1 we will calculate the acceleration. So just now we have calculated force is 4.885 into 10 Newton. So if we will multiply that 10, that became 48.85 Newton. So don't get confused, sir. Just before you have written 4.885 into 10 Newton, and here you have mentioned 48.85 Newton. It is not different. Just I have multiplied that 10 to 4.885 and that became 48.85 Newton. So I have written that value here. Mass 1 is 5 because M1 was 5 kg. So the answer is 9.77 meter per second square. And for M2, what is M2? 6.6 into 10 raised to 24 kg. So the force was remain same. M2 is 6 into 10 raised to 24 kg. So the answer will be A2 is equals 8.142 into 10 raised to minus 24 meter second square. Right?
Yes, sir.
So here ends model number
4.
4. We'll go for model number
5.
5. Okay. Pay attention. Just now we have completed model number 4, one numerical based on gravitational force, acceleration due to gravity. Now it's time to understand small g.
Yes.
Okay. Acceleration due to gravity, acceleration due to gravity on surface, and acceleration due to gravity at height. So these parts we have to understand to know more about acceleration due to gravity. So considering Earth, there is a gravitational field which is very specific and which is very limited to Earth, right? So we have mentioned a dotted line to represent gravitational field, and if the object is in the gravitational field, that we have shown with the red dot. So there must be force of attraction towards the earth. So as F is equals ma, therefore A is equals
F
F upon
M.
m. This is called acceleration due to gravity. This is what acceleration due to gravity. It is represented as small g. Now we have to derive the unit of it, but we are aware that F is equal to capital G m1 m2 upon r square. So here two masses are there, the object which is represented as small m and the earth which is represented as capital M. So considering that F will be represented in terms of G, capital M, M upon R square, and initial M was there, small m.
Yes.
So we will consider that, but that small m will get cancelled. So finally we have small g is equal to capital G, capital M upon R square. Capital G is what? Universal gravitational constant. Capital M is what? Mass of Earth. And small r square is what? Distance between objects. Means center of Earth and center of that object. In दोनों के बीच का distance is represented as r. Acceleration due to gravity on surface of Earth. Previous case it was in the field of gravity. Now we will consider it is on the surface of Earth. So now object is very closer. Consider an object of mass on the surface of Earth. As the object is inside the gravitational field, there is a gravitational force acting towards the center of Earth. That is known to everyone, right? The direction will not change, only distance has changed. The object was in
outside the gravitational field.
It was in the gravitational field but away from the earth's surface. So force, the gravitational force is same as the weight acting downward. So weight is equals gravitational force. If G is equals acceleration due to gravity on the surface of earth, then weight is equal to mg, mass into acceleration due to gravity, mass into acceleration due to gravity. So mg is equals the formula which we have derived, considering the distance r. So capital G, capital M into small m, and r square was the formula which we have derived. So the small m and small m will get cancelled. Sir, here the r is capital. In the previous case, the r was small because distance was quite more. But now distance is exactly equal to the radius of earth. Exactly equal to the radius of earth. SAQ, because object is on earth, right? So there is no gap between radius and the person or the object, right? So we can consider capital R, even though if we are considering the center of that particular object is lying at some feet, 40, 50, 5 feet, 4 feet, but that is very much negligible looking at the radius of earth. So even though if we will consider that distance, value may not change more than 0.00 points, right?
Yes.
So that's why we have considered capital R, capital R. So small g is equal to g m upon r square. So if we will put the values, now we have all the three values.
Yes.
We know the capital G, that is 6.67 into 10 raised to minus 11. Mass of earth is 6 into 10 raised to 24 kg, right?
Yes.
And radius of earth is 64 into 10 raised to 5 meters. In case they may not ask this in the CET JEE or NEET, but they may ask you to derive or they may ask you to calculate the values of small g. So the value of small g is 9.8 meter per second square. This is the value of acceleration due to gravity on the surface of earth. Yes, it is right that on the poles the value may change, right? The value might be 9.83 meter per second square. So third point, acceleration due to gravity at height from the surface of earth. Consider an object mass m at height of earth, and that is considered h from the surface. H from the surface. As the object is inside the gravitational field, there is a gravitational force acting towards the center of the earth, which is again same. The gravitational force is same as the weight acting downward, so weight is equal to gravitational force. So if GH is the acceleration due to gravity at the height, then weight must be mg suffix h, and our formula, considering capital R plus h. Capital R is what? Radius of earth, and above earth the object is at height h. So we have written r plus h the whole square. Now again this m and this m will get cancelled. So acceleration due to gravity at height from the earth's surface, GH is nothing but capital G capital M upon R plus H the whole square. Right?
Yes.
Now it's time to answer few questions. So two questions are there. First we will see the prerequisite knowledge and then we will answer it. Acceleration due to gravity on the surface of the earth is independent of. So what do you think, what must be the answer? Himanshu, what must be the answer?
Universal gravitation constant.
Universal gravitational constant. Hitesh, what do you think? Universal gravitational constant. What do you think?
Universal gravitation.
Okay, we'll see. This was we have discussed earlier. So G is
Mass of the body.
mass of body. Acceleration due to gravity on the surface of the earth is independent. It is not dependent on mass of the body of the earth. Why? Every time we have cancelled that small m.
Yes.
If you remember, every time we have cancelled out
Small
m. So pay attention. Right? Second, the mathematical formula for acceleration due to gravity on the surface of earth is
GL upon R square.
so G is equal to capital G M upon R square. So here ends model number.
5.
So it's time to understand model number
6.
Okay. Now we have discussed model number 4, 5. In model number 4 we have discussed numerical.
Yes.
Model number 5 we have discussed about small g at different locations. Third point might be that g is at depth. That can be possible. So due to gravity we have seen relation between acceleration due to gravity at height in terms of acceleration due to gravity on the surface. Now we have to see the relation between that two conditions. Just now we have discussed in model number 5. So expression of g at the height in terms of g on the surface. So at the earth surface g is equal to gm upon r square, right?
Yes.
And gm is equal to
GR
gr square. Gm is equal to gr square. So here I can change this gm with
GR square.
gr square. Correct? So formula became gh is equal to gr square upon r plus
H
h the whole square. So finally, if we consider that g aside, then taking the two variables which are having square in the numerator as well as denominator, so we can write it separately as r upon r plus h the whole square, right?
Yes.
So this is another formula, second formula to derive the same expression. This is the expression for g at a height in terms of small g on the surface. Small g is acceleration due to gravity. Expression of g at small height. So as I said, that height must be neglected. So let us see what happens to that height. So what we have done, there is no need of taking that in the inverse, but as we are decreasing the height, we need to understand what happens if the height goes on changing. So just for consideration, I have taken that r upon r plus h in the denominator. So it became transpose of it r plus h upon r. Value remains same.
Yes.
But if I separate it r into r plus h, so I can write 1 plus h upon r. Because after calculating this again, 1 plus h by r, so r ones are r plus h, so that became r plus h upon r. So value is same, right? As I need to focus on height, I am just changing this derivation in terms of height. In terms of height. I hope you understood.
Yes.
Right? So we'll go further calculating that this raised to 2 other concept in the denominator, once it goes in the numerator, that became minus 2. Value is same. So here, whatsoever may be the height, we have added with the series. So 2h upon r plus h upon r, right? So there must be a series of 1 plus h upon r raised to minus 2. If we will put the values of h, 2h, h, so on. So h is very less than capital R. H is very less than capital R. What is capital R? Radius of Earth. In the previous module itself, I have explained that even though the center of that object which is lying on the surface of Earth is 10 feet, 20 feet, 40 feet, whatever it may be.
Yes.
But looking at the radius of Earth, it is very negligible. So we can neglect the higher orders of h plus h upon r. So we get 1 minus 2h upon r. So now it's time to go for MCQs. Values of small g at a height 320 meter from the surface of Earth. Now it's time everyone to calculate the values. Start calculating. We'll see what will be your answer. Everyone, those who are watching, they can also calculate the values and we'll see what is the correct answer. Height is 320 meters. Height is 320 meters. And we know the formula capital R plus H. As the height is very small, we have considered the formula 1 minus 2h upon r. Value of small g is 9.8 and the radius is 64,000 kilometer, that is 64 into 10 raised to 5 meters. Putting the values, h is 320 meters.
Yes.
So calculate that and find out the answer. Multiplying it with 2, 320 became 640. Once it gets multiplied with 2, so 64 and 640 get cancelled. So answer is
10
so 10 raised to minus 4. The correct answer is 9.799 meter per second square. Usually, student just click on 9.8 meter per second, right? But it is not like that. It is 9.799 meter per second square. So it is very much obvious as height changes, the value will change very minor, right? Even though if you will calculate it as 9 point, if you will consider it as 9.8, again it is correct. Considerations are correct, but actual value is 9.799 meter per second. Otherwise, approximately we can consider it as 9.8. But to calculate it very precise, considering 320 meter, answer must be 9.799 meter per second. Second question, acceleration due to gravity at a height from surface of Earth. So we have to select the correct formula. So this is what we have derived. GH is equal to GR upon R plus HG whole square. This is the expression of G at height. Right? So this is the correct answer. Answer is
A.
GH is equal to G in bracket capital R upon R plus HG whole square. Okay. Now the next question, acceleration due to gravity. Acceleration due to gravity at height above the surface of Earth is 1%. That on the surface of Earth, the height from the surface of the Earth is. Now this is the relation. This is what? Relation. So look at the screen how to calculate that, because in CET, NEET and JEE such type of tricky questions are asked every year, and students generally does not understand what to do in that question, right? So look at the screen for the solution. We have formula GH is equal to G R square R plus HG whole square. Now what they said 1%. What they said 1%. So we have mentioned 1 upon 100 G. So GG cancel, small g got cancelled. Here sir, why that 100 became 10? Because we have taken square root on both the sides. So here R square became R plus H square became R plus H, and 100 square root of 100 is 10. So that's why 1 upon 10 R upon R plus H. By cross multiplying you will get H is equal to 9 R. Right? Very important question it is. This can be asked in the upcoming 2022 CET, JEE or NEET. So if you have to revise it, again go on the video, pause it, note down the solution. So here ends the model number 6, and here ends the part 2 of gravitation. So we will come again within next 5 minutes for part 3, which will cover up model number 7, 8 and 9. So stay tuned for this. Meanwhile you can revise. Right? Thank you so much.